right, I would like to thank all the speakers, Chantel, Benny, and Paul, for those insightful presentations. So before we start with the panel, I would like to have few questions for Michael and Joe. And then I would like to open up the floor to the audience questions and discussions. So for Michael, I would like to know, like, from the train control systems perspective, like CBTC, like that's a communication-based train control technology. How do you see digitization or IIoTs impacting that industry? And then I would also like to answer, I would like also like Joe to answer that from the supplier's perspective.
Okay. All right, Pravo. Thank you very much for inviting us. For those who don't know, CRC stands for China Railway Signaling and Communication. We provide train controls. We're actually the largest train control supplier worldwide. And we do a lot of high-speed rail freight and metro. CBTC is one of them, Pravo just mentioned. To answer your questions, in my view here, CBTC, of course, the goal was the latest technology used for the metro, like New York City Transit, like a BART, like Toronto, transit system here. They use the latest technology, allow the train run closer each other, still maintain the safety. We're in the safety business. Signaling is in the safety business, ensure train to train never collide each other. But the best way you stay far away, right? But then your efficiency is low. So I want to stay as close as possible, particularly in the metro environment, yet to be safe. So that's what CBTC does, and it's called a communication-based train control. So we do see, this is a new technology, more and more adopted by U.S. customers. It's a kind of standard in China, Europe. People already accept it as a best technology. Normally, most 99% project in China today is CBTC, but U.S. because the most transit system has been old, been built a long time ago, sometime over 100 years ago. So CBTC has not been well accepted as the best option. People are still debating, what's the options for them to improve. But we see definitely CBTC are become more and more accepted in the U.S. market, and the CBTC allow you best utilize your asset, have a best we call it headway, yet remain safe. A second thing here is that the digital. CBTC also allow you a lot of more digitization of the system, allow you to have a much better efficiency in terms of operation, maintenance. Like our CBTC come up with a 3D monitoring system, allow the people in dispatch monitor all the equipment status. So you don't really need to send people over there in the equipment room to check the equipment. So it's always there's 3D in your control room, so you can cut down 40% maintenance costs. So a lot of data, as Paul mentioned, a lot of data there. It doesn't matter how we utilize them, and we see customers more and more requires data to improve their maintenance, improve their operations.
Right. Thank you.
I think railroading has gone through a couple of golden ages, right? I think we're at the advent of the next golden age, and that's the age of data and communications and insight. Any system that we can install out on these networks that provides more information is going to be ultimately better for the folks that operate on those networks, right? And it's great if you're a data analytics company too. But now that we have PTC, really we're beginning to collect all of this data and now have the ability to aggregate it. But what's really interesting to me is that now all of the Class 1 railroads across the U.S. will be collecting very, very similar data sets. And I imagine that there'll be a lot of synergies that they can then share, a lot of learnings that they could share across those organizations. Certainly, safety is probably the number one biggest impact there, but you can also do a lot around efficiency and scheduling, I believe, too. So it's very, very exciting. I think this is a huge opportunity for not only the folks who operate railroads, but the shippers and everybody down the value chain as well.
All right, thanks. So I would like, I have a question for any one of you can answer, or everyone can answer. So so at this forum, we have been seeing all the industries like oil and gas, pharmaceuticals, cybersecurity, all trends and innovations that are happening. So in comparison to other industries, how do you see rail industry is addressing or being accepting towards the change that digitization has to offer to the rail industry? Would anyone like to comment on that?
Well,
Oh, you can use the microphone.
In terms for CSX, and I think many of our other Class 1 partners, we are trying to embrace it in terms of we're looking at everything from machine learning and machine vision for what we can do there. We have very high costs that are associated with track inspections. We have 400 people out there. They do it all manual. So we're looking at opportunities here where we can utilize drones. We're looking at opportunities where we can use machine vision on our locomotive to inspect the track for us and supplement what our track inspectors do today. So I just, again, you called it the age. It's a new golden age for the railroad. I would agree with that. And in terms of it's very costly for us. It's not what we specialize in. So we're continually looking for opportunities to do that. The predictive analytics for us is huge. We are utilizing that across multiple departments with CSX as well. Just lots of opportunity there.
All right.
Yeah, I agree with Chantal. I mean, from the technology side at CSX, I mean, we are constantly looking for better ways to take the data and drive value from it for our business partners. Taking their business problems they're bringing to us and really looking at where do we have opportunity to utilize that technology in ways maybe that we haven't thought of, historically we haven't done. And I think also with the changing millennial generation coming in, that is a huge driver for the railroads. It's no longer, like I said, like we talked about, it's not your father's railroad. It is very much a mobile, data-centric organization now.
I'll say one of the things we've seen in shops, right, where locomotive shops, to your point, there's a bow wave of the older generation retiring, getting to be my age, leaving the railroad. But these were the people that knew what was wrong with the locomotive by listening to it, right? Just because they'd been around it, they grew up in the locomotive shops, been around it their whole life. Now the next generation is certainly willing and computer savvy, technology savvy. And so it's a perfect time to provide that technology in a way. Not only does it help them get to the answer of what's wrong with the asset quicker, but it's also a training tool, right? As you use the tools that are out there and available to troubleshoot and get to the root cause problems, you're actually bringing up the learning curve a lot faster.
Well, I'd like to share one example here. Definitely this is a technology in the rail industry I can share. I learned from China. We talked about earlier in the breakfast. China is also a big freight country. There's a lot of yards here. It used to be the yard system is very manual. You engage thousands of employees to do the sorting. Today, many yards are very automated. Sometimes we call it one-man yard. One-man yard. It's not really one man, but it just means a very few people, very automated. People stay in the control room basically. A lot of manual spot was basically replaced by automation, by data collection, auto control. So a lot of those technologies being used to increase the efficiency of the yard sorting business, and yet cut down the cost dramatically by reducing the number of people required.
Yeah, I mean, we're involved in many different verticals, right? I mean, we're working in aviation, manufacturing, construction, mining, and certainly rail. And we see rail being at the forefront of this technology. The fact that we can have the results that we have and they're quantifiable speaks to the adoption that we've seen in the rail industry. It speaks to OEMs being aggressive with pushing the technology, and then certainly consumers accepting it. And you would maybe look at rail and aviation and think aviation would be light years ahead, but that's actually not true. And rail is at the forefront of this adoption curve, and consequently they're beginning to see real quantifiable results, which I think is pretty unique. Even in the few days that I've been at this conference, it's nice to see outcomes, right?
Thank you. So I would like to open the questionnaires to yes. Thank you.
One thing that I did not hear from anyone is anything about driverless trains. We're hearing a lot about driverless transportation in other areas, and if so many of train accidents are due to human error, what is your industry doing to try to take that factor out of the equation?
Thank you.
I'll jump in for this one. So I'll let my counterparts from CSX talk about North America, but I'll talk about, our company is involved with, we call it ATO, Automatic Train Operations, a project in Australia. And the reason that it's easy to socially to move to driverless trains is because it's in the middle of nowhere, right? So we're talking about in the outback in the Pilbara region, going from a mine to a port where you don't have the road crossing interactions or the possibility of hitting a car, of taking a human life, right? You don't have the possibility of, it's not a huge city, right? And somebody just can't roam onto the track. So in those types of environments where you can control, where you're in a controlled environment, a very unpopulated area, driverless trains are beginning for big freight operations. And I think it's going to be a social issue in the U.S., right? You have many more opportunities at a rail crossing for, something to foul that crossing, for a truck to go over it, for a person to be in the way of the train. And PTC, I think, is a step in the right direction. But I think it's coming, and I'm gonna let you respond.
So it's something that we have looked at. The advent of PTC required us really to look at it. Again, PTC for us is really supplementing the person. So I would completely agree with the urban areas and what's going on there. In terms of making the statement that it's always, that, the majority of them are, caused by people, I'd want to go back and go double check that one. But there's a variety of reasons why accidents do happen. But we have seen where we've went from 5-man crews to 3-man crews to 2-man crews, and we operate as 1-man crews in our yard with remote control locomotives. So we have been there, but you just cannot get away from the person there visually seen, because as much instrumentation that we can do, where we're at right now technology-wise, there is the human person who can see something that the locomotive can't see and can stop things from happening. And that's the safest opportunity that we have right there, which is we want every way to stop an accident from happening, whether it comes from the PTC stopping the train or the person stepping in to do something with the train to stop it. But I don't think from a United States perspective, we have regulatory issues that require that. Even going from 2 to 1, we've had to overcome regulatory hurdles. Going from 1 to none, we just don't feel as though we're there yet from a freight perspective.
All right. Michael, would you like to talk on?
I'd like to share some of my thought here to your questions. Driverless technology actually is quite become more and more popular in the transit operation. I don't see a whole lot in this country, United States. Most transit properties we visit here, because of union issue per se, they actually don't like this idea, because the union don't like the driverless. And but outside United States, Europe, China, Japan, you see more and more driverless metro system there. There's 2 levels. One is called in the ATO, automatic train operation, which basically is everything's automatic, but you still have a driver sit there just in case there's emergency, or just push a button to start, that he just sit there and watch. And versus completely driverless means there's even no driver console anymore. You have that nice window, people can sit there and see the track. So all those are increasingly popular. Technology become more and more mature. And you see that, if you go to Paris, several lines are already being upgraded, become a, line 14, line 1 in Paris is already running for several years, completely driverless. So this is clearly a direction in the transit world is heading into.
Yeah, I would say that, PTC and ATO get you most of the way there to a fully driverless train. I think that you'll always have, at least in the United States, you'll always have a supervisor who's sitting in the cab just to make sure everything is going well. Interesting, Boeing released a study, it's pretty easy to find. They realized that a lot of incidents with aircraft are caused by people making the wrong decision. And that it could potentially be safer to not have a person in control of the airplane. But I don't know about anyone in the room, but I like to get on an airplane and see a nice gray-haired man about to fly me somewhere. So, there's a perception issue too that I think is very difficult to overcome.
All right.
So I'll make one final comment on this, and you can look this up. This is actually another one's relatively easy to find. People are more comfortable with self-driving cars than they are self-driving trains. Think about that.
Interesting. All right, anyone else? Oh, yeah, sure.
So we've been hearing all week from various excuse me, industries who fall under the umbrella of critical infrastructure and how they're preparing for cybersecurity. And I'm curious as to where you feel the rail industry sits in its level of preparedness in cybersecurity.
So I would say that definitely the freight rail network is definitely recognized as a national security asset, right? We move lots of military equipment, some of it, obviously confidential and that types of things. And so we are a constant target. We have a very robust security program that's in place. We are constantly checking it. So I feel from our standpoint, our systems are very robust and secure. Obviously, as we push digitization out farther into our rail networks and have that Internet of Things out there, we've got to make sure we have the right controls in place to ensure that our core network is protected. So I think we're staying ahead of the wave for now, but it's definitely requiring a lot of due diligence on our part to make sure we do stay there.
As a supplier, I'll say that everything, so we don't remotely control locomotives, right? But we get, I would call, non-critical data. It's critical relative to the health of the locomotive, but not to the operation of the locomotive. But we have to think about it from data transmission to data storage to when we're making sure that the analytics environment is a secure environment. So it's in everything that we do. And because we're an international company, there are different requirements in Australia for how you handle data. And in some cases, data can't be moved, so you'll have to set up an instance of a cloud in that country, right? That it can't come out of that country to the United States. So we think about those things every day. But data it's so important that we can show to our customers your data is safe, that it can't be breached, it can't be accessed. Everything from transmission off the locomotive to we send data sets to our analytics partner where we actually share the same cloud infrastructure, which helps in security, but it's critical to everything that we do.
Interesting. So, okay, go ahead.
Just one more, today, if we see our customer when they buy CPTC technology, cybersecurity is a part of the requirement that you need to have a built-in cybersecurity functionalities in our train control system.
Yeah, cyber is wrapped into everything that we do. Uptake has a contingent from our cybersecurity team here at this conference, specifically because it is so important, and we want to make sure that we're staying abreast of everything that's going on. But from encrypting data, all the data in transfer, whether it's in arrest or moving, all of those things are extremely important. And then certainly, it boils down to that person who's logging in and making sure they're appropriately credentialed and seeing what they're supposed to be seeing. And I think there's a ton of opportunity as we begin to connect more and more sensors to the cloud and to these various networks. And that we might be very, very good at monitoring a locomotive and predicting a failure on a major component, right? But because we've been able to see so many locomotives and so many signals from so many sensors, you can start to say, well, that sensor is always telling me this one thing. Then all of a sudden, it starts to tell me something different. Is it that the sensor itself is failing? Is it that another system on board, the asset is failing? Or is it that someone is doing something on board that maybe they shouldn't be doing, or they installed something on board that maybe shouldn't be there? So you can begin to infer things on those assets and help keep them even safer. So it's one of the ways that we look at it.
So I have a follow-up question for Joe. So as a data analytics company, or you working with data scientists, so trains travel through remote locations, and there is a high probability of losing data where you don't get enough data to actually come out with a result. So how do you collate the data in terms of trying to understand what the final result is if you don't have enough data?
Yeah,
and the same question would be for CSX as well. Like, your trains have been traveling all across the regions, and how do you manage the similar if you don't have enough data to take some countermeasures on it?
Yeah, it's interesting. We've stood up a 24/7 monitoring center that monitors these data streams and flows, and it's complete with alerting and data segregation technology that allows us to kind of quarantine things that may seem anomalous or something comes that we don't expect. We certainly would never let that into the system. But you can imagine that monitoring thousands of locomotives all over the world, each one of them is communicating on a different frequency. Right. They are saying slightly different things because they may have different sensor packages installed, right. And all of that data needs to flow into a singular platform, run through data science models, and then the outcomes must be produced in a timely fashion, right. Especially in rail, because what we learned, what Uptake learned, these guys already knew, but what we learned through the course of this process is it could take 5 to 7 days to get a locomotive to a shop. So I can't tell you that you're going to experience a failure 3 days ahead of time, because that's really not good information. It's not going to be able to be acted upon. And if we're not moving KPIs for an industry, if we're not actually driving change, then there's no real point in doing all of this work in the analytics and the processing. So we're very conscientious of how that data flows in, and then how timely we can process it and get that insight back to the people who need it. And all of that entire data ecosystem has to be closely monitored and controlled so that we know exactly what's moving where at any given time. And there's a large team that's responsible for that.
Absolutely.
So I'll speak from the business side, but not the data stream side of what they manage in technology. But I'll speak to two things around what happens when you have loss of data and where does it go. So surprisingly enough, many of our systems are still it's manual information that goes into it, and so we have about 200,000 cars online at any given time that we're managing. And we lose cars. We lose rail cars and don't know where they are, surprisingly enough. So there's not enough censoring that's out there because sometimes people just don't report the right information. So we are still in that area that we do have literally loss of assets. You can say it that way. We find them, and eventually they go by cameras, and we know where they are. It's a very small amount of our data. But it does happen because we do still require, in some cases, out in the middle of nowhere where we don't have cameras, and we rely on a person who's moving the train to report where he left the car. So that happens. It's unfortunate, but it does. On a more global level, from a operating perspective, as much as we've outfitted our teams with iPads and mobility to report data, and locomotives and GPS, and where is the locomotive today, we're still challenged with those dark spots of mobility. And we, unfortunately, try to report real time. I'm trying to understand, if I have a signal maintainer who's out there working on a signal, can he get the information back to me remotely? And we have those areas in the middle of the mountains that we just don't have that coverage, and it's tough sometimes for us to get that real-time level of data. It could be 8 hours. It could be until he gets back to a spot where all of a sudden the data syncs. So we're challenged from more of the operating perspective of what goes on with data. And I don't know if you want to comment about the behind-the-scenes transmission of data, because...
So I mean, we've heard great perspectives here, but I'll give you a kind of a technological view of it. I'll talk about our geometry cars. So we've got cars that are outfitted with cameras, LiDAR, lasers, et cetera, that we run over our network typically at least twice a year. And these do a very granular level of analysis of the rail itself, the ties, the ballast, the vegetation around it, the whole 9 yards, the clearances, to identify where we may have potential failures occurring. Our challenge is that we generate so much data from this car, we cannot get it all back to our data center in a timely manner, get everything back. Even if it's sitting in one of our yards, having a Wi-Fi connection to the internet, we're talking terabytes of data per day that are being generated by this car. So typically what we're doing right now is we take and we get the most critical data uploaded back to us in a timely fashion so we can address critical issues. But then we bring that data back, and literally we load hard drives about every week from these cars. And that's the only way we can get the data back in terms of the sheer volume of it. Right. Now, as we get 5G data and things like this, and as networks become faster and faster, hopefully that improves. But that's one of our key problems right now is we got the data out there in the sensors, et cetera. How do you get it back to the data center for analysis in a timely manner?
Great. So any questions in the audience or, okay.
Hi, my name's Crick Waters. I'm with a company called Falconry. Benny, that's a great question. Have you guys started to look at doing on-car analytics? So you can break out some of those data streams that are most critical and do real-time analytics on those data being collected from the geometry cars?
We have. We actually have a significant amount of analytics already on the car. I mean, it's looking at things like gauge, it's looking at rail wear, et cetera, and highlights for the operators of the car, hey, there's something here you need to do it. And we call them red tags, right? Where, yeah, we've got to have somebody come out and put physical eyes on the asset to check it, to say, is this truly an issue or is it a misread, false negative, whatever you want to call it. We do have a significant amount of analytics there, but we talk about being able to go back and look at a 70-mile run when you've got data points literally from every inch of the rail along the way. Just the sheer volume of capacity of that data on the car is just not, at this point, we're not there yet. And I mean, this is one of our cars, TGC3 is what, 2 years old?
TGC3 is our newest car. We have 4 actual cars, actually 4, and then we have 2 that we're in progress right now. The first 4 are all manned, so we have locomotive engineers moving the cars for us. Usually our signal teams and our maintenance of way teams are on there. So we utilize the FRA regulations in terms of what we consider to be a critical failure. We immediately will stop and look at it. And we typically have maintenance teams who are riding behind us as well who will immediately address a critical failure. We also are now investing in 2 non-manned cars that will actually operate in our regular train network. So it looks just like a box car, but it's completely outfitted with some of the similar machine vision, LiDAR and everything else that will operate on its own unmanned, and we will be trying to transmit the data back to us as well. So 2 different ways that we address it, both with the manned vehicle and processing data live for critical failures, and then we will have the unmanned vehicle. We have one right now that was just deployed, and we are working on our second build right now.
And I'll say from a locomotive perspective, there's data gaps that we've learned going through this process of saying there are, and once you learn those, I can't predict a traction motor failure right now from a gear case oil, right? And so because it's very, very difficult to sense, it's something that it's a very dirty, greasy area of the locomotive. People really don't want to get down there and check the oil level on a regular basis, but it's a significant cause of failures when the gear case oil, is empty. And so we've developed wireless sensors that give you the gear case oil level, which is something that we're deploying this year. So you learn as we look at what coverage do we have the locomotive, what are our gaps that we need to either sense to get additional data to build the models around. And then I'll talk about the predominant way of getting this data off a locomotive is a cellular network, right? Well, you have to be very, very cost effective in your strategies of only you collect and store data. You only want to send off the critical data if it's part of the data that you need to predict a failure before it happens. But then you can, when you get to a yard and you've got Wi-Fi available, then you can send off the bulk of the data. And we're also, I think, more and more is going to move to the edge, right? Locomotives are a big computing platform with a lot of capability, and so we'll move more of the analytics as we can to the locomotive itself. That way you don't have to offboard the data and you don't have that cost and the worry of the data security. So I see more and more of the suppliers going to the edge for the analytics, but first you gotta build those algorithms, and you gotta deal with the massive amounts of data and understand what's really critical.
Right.
Yeah, I think the other thing I would just mention real quick is one of the things we did probably 5 or 6 years ago is we definitely started referring to our locomotives as mobile data centers. Because when you look at it, we have storage on there, we have compute power, we have networks. And they're little mini data centers rolling around, and it's a matter now of figuring out how do you connect all of those back to the main one, right? And putting some of that processing on the edge and saying, how do I take and look at, engine diagnostics or track sensors, et cetera, and make a compelling case for saying, yeah, I can do that here and get the right resources in the right place based on that data.
All right, great. So I'll have a follow-up questions on the challenges in terms of technology that we have been seeing. Rail is always under pressure to leverage the technology in terms of efficiency, safety, reliability. So as technology develops and new challenges will keep coming up, so from the perspective of suppliers and the operators, how do you see in terms of, do you see any new investments that are need to be done in terms of what rail operators want or what suppliers want, eventually leveraging this technology? So do you want any new investments that has to go through in this industry that will eventually help?
We may have already touched upon this. We had started down a path last year of really looking at new and innovative technologies on the railroad. We were looking at putting together really a centralized team who only looks at predictive analytics. We were bringing in outside vendors to look at doing automated track inspections from a locomotive. And so we had that in there. We unfortunately have cut back, because we are looking at our investments right now and where do we want to spend our money. But I will tell you that some of our other Class 1 partners, and we're going back there, we're trending back in that direction. Right. We will be looking at things more wholeheartedly around drone technology, on the edge mobility. Our mobility platforms are not standardized across each of our groups. So I will tell you, just in engineering itself, we had different groups who manage signals and comms versus bridge versus track. And, one of the roles when I joined that team a year and a half ago was to try to figure out how do we start to look at engineering as a whole. So our enterprise asset management systems, we are now consolidating and centralizing that. So we are investing a significant amount of money to centralize all of that data into one platform. But I think, drone mobility, it's a huge investment, but I think what you're going to get out of it from a safety perspective and efficiency perspective, we've heard that message across the last few days. It is significant. You need to be able to quantify it, and there's great ways to do that. And that's where I think some of the challenges, but where the opportunities really lie for us going forward.
So not to reiterate everything Chantel said, but I think from a technology perspective, our side of it is to look at what are those infrastructure, those IT platforms that we leverage going forward to consolidate the data down and provide that analysis, right? I don't need analysis done overnight. My business partners need it literally in minutes, not hours. So how do we add that level of delivery to give those answers? Mobility. I mean, for us, I don't want a guy to sit there and go ride the rails for 4 hours, come back, and then sit down and input his results, right? It should be on the fly. He's able to do it right where he's at. I think that's going to be huge for us across our entire company. And thirdly, I think the whole idea of the instrumentation of the network, right? When I say the network, I mean the rail network. So we talked about, locomotives being outfitted with lots and lots of sensors, being able to pull that data back, and our rail being able to have that, and our trucks. The whole idea here of knowing where our vehicles are and being able to, one of the business cases we're actually talking about right now is if we've got a train and the train goes into what we call emergency, right, which means that the engineer knows there's something wrong with the train, rather than the engineer or the conductor getting down and having to walk literally a mile back to inspect the train, what if there was a track inspector within a couple miles in his truck and you knew where he was? Could you have him go to the end of the train and do that inspection for you? Once again, reduce the train delay, reduce it, give the customer back. Those are the types of things where I think talking about mobility is, to me, is the biggest thing I think we need to invest in as an industry.
Right.
I'll say for us, the investment is in data collection, data acquisition, and data storage. And it's expensive, right? And so you really have to determine what do you really need to collect, what do you really need to store versus what's the noise, right? And then I'll tell you just examples of some of the technologies that we're looking at differently is a drone in a box, right? So you have a drone that's on a locomotive, and when you have a TIH train, a chemical train that can, if they have a derailment, can release toxins, you don't want a human to go back there and have to manually inspect that. So, an example of a great use of technology is the drone, leaves the engineer launches it from the locomotive, flies back to the end of train device, which provides another signal for the proximity of the train, and just do a visual inspection of the entire train without exposing a human to, hazardous material.
Cool. Joe, would you like to talk?
Okay. From our perspective, I think one thing I already mentioned earlier is driverless technology definitely is one area we're trying to invest and mature that technology more and more. The other area I'm trying to point out here is that particularly in the U.S., because a lot of railway systems, are very old and built a long time ago. So there's a limited new project, but a majority of projects upgrades. That is, we call it brownfield project. So if we do a brownfield project, it's different than a greenfield project, which require completely different way to do it. So we're really looking, learning or investing. How do we deploy brownfield project more efficiently, lower cost?
Yeah, and I think it's about connecting the entire ecosystem, right? I mean, you've got all these organizations have many disparate data sets and many different ways of even moving data from one to the other if they can do it at all. So trying to provide a layer that that can actually add value to the data that these folks are sitting on. Everybody has been collecting data for years and years and years, and nobody wants to press delete because everybody says there's a lot of value there. You can't get rid of it. Unfortunately, it's been a struggle until this point to really begin to unlock the true value of that data and look at it, network wide.
Right.
So I think we're at the precipice of that, and I think that there are platforms out there that can help with that. But then beyond that, I think PTC is a worthy investment for a lot of reasons. Certainly safety, but also because you can now aggregate that data and collect it from across your entire network. You can do clever things with switching. You can reduce train delays. That coupled with locomotive monitoring and wagon car monitoring, could really impact a business in a big way. So I think like I said, it's part of that golden age that we're coming up on.
Okay, go ahead, sir.
Question for the entire panel. You think about the things that impede speed of advance across this objective. Would it be something like the digital infrastructure or architecture, corporate culture, technology availability? Does it exist yet? Budget, human resource factors, like availability of your own teams? Or is it a backlog of legislated or regulated projects that have to get done first? Those are 6 different things I thought of that might be slowing the speed of advance.
That's a great question, though.
Yeah, agreed, all of the above. I mean, you look at it, for us, positive train control, right? It's been a big project. We've taken a lot of resources over the past 7 years to get that project where it is now. We still have a couple years to go. But then when you start looking at resourcing, how do you get the right people, hire the right people who have the skills you need? That's difficult. Budgets, there's always competition, right? For where are you going to spend your money, right? Limited amount of money, who gets it?
And we laugh because Benny knows that this is an interesting topic for us because the last 2 years we've actually had in engineering, we have been really trying to get our systems up to speed. We actually have more technology budget dollars now than we do have technology people to work on it right now. So whoever runs into that, we are always normally asking for money, but we've got more work to do than, we have more dollars and work that we want done than we do have people to do it. So looking outside of us sometimes.
It's a very good problem to have for me, right? But no, I think like I said, it is all of the above. It's just to varying levels and degrees.
I would say it really comes down to data that delivers results, right? Everybody is constrained by budget, typically, right? And so if we can pick those projects where we can demonstrate value of the investment, then that's where you got to start, right? So that for as a supplier, you have to be able to say, I'm going to make an investment and know that I'm going to be able to show my customer that it's worth spending the money on.
Yeah, I think if you have a really good analytics solution, it should actually be paying you. You're going to spend some money for that solution, but you should be receiving times 5 back in ROI. Just by reducing costs and increasing efficiency, increasing availability and reliability of your fleet. That would be the goal, I think. And I remember, I remember the first time that the uptake team went into a rail yard. And a lot of people, a lot of guys in their 20s and 30s maybe, walking into a rail yard with shiny new laptops, telling these folks that they were going to be able to predict the future and tell them that locomotives were going to fail before they did, and before the first fault ever fired. And some of the folks with wrenches in their hands weren't too, I guess, accepting of that, And so it was an understanding of the different cultures, and I think not necessarily a blocker, but certainly something that we had to learn, and how to relate and how to actually deliver insights in a way that they were most acceptable for the people who really needed them. And there was a lot of work there that I think was time well spent.
Great, thanks. Any final comments? We have 2 more minutes. Any last questions? All right, so I have one last question. So beyond digitization, do you see any other factors impacting the industry going forward in next decade or so?
So the one big thing for us is regulatory issues. I mean, regulatory in many cases define what we're going to be working on and what we can and can't do. It really, in some cases, puts the scope around what you can do. And so for us, as we think about technology moving forward, we are in lockstep thinking about what we can do with our unions and with the regulators to be able to achieve where we think we want to go. So it's part of our standard business practice now is to engage on the front end. We are outfitting right now, we have movable bridges. So these are bridges that go up and down, and we've had a bridge tender who sits there and he literally waits for a train to show up and he hits a button and the bridge goes up, right, or comes down. We shouldn't need people to do that anymore, but we've had to go and work with the Coast Guard to make them understand why we want to take the person away from the bridge and use visualization, use censoring of if there's a boat coming, working with the marine agencies. So those are the kinds of things where we know where we want to go, but the challenges with the regulatory issues that we have, whether it be the FRA or outside, in this case, the Coast Guard, what we have to overcome to get there.
Interesting.
I think from the technology perspective, number one, analytics, I think is the biggest disruptor for the next 10 years for us.
Okay.
Once again, taking all that data and being able to derive insights from it. Another thing that I think is going to be huge for us in the next 10 years is going to be augmented reality.
Okay.
Right, that's going to be huge, especially we have the folks coming in, folks retiring, new folks coming in. That's going to be huge. And lastly, I guess that's the 2 for now.
All right.
From our perspective, it's the next generation of design. How do you design all of our products, right? How do you make them more efficient, more reliable, more available? And I think battery technology, it's proven to be effective on smaller vehicles. It doesn't scale yet to a locomotive, but it will. And so we're tracking that technology very closely. First, start with a switcher, 0 emissions, right, when it's in a yard, and then ultimately move to a road locomotive. But we got to keep an eye on that for now.
Great.
I think from our perspective, it's similar. I already mentioned here, we're in the safety business, but we're also now in the business of delivering better efficiency, operation maintenance efficiency to customers. So we definitely need to, looking forward in that direction. How can we further increase our, offer to customers and different, allow them to have better payback.
Yeah, I would go back to just working to connect all these different sensors and connect that ecosystem and get these organizations looking at the same data set, reporting metrics based on actual information, factual information that's cleaned and normalized, and not polluted with maybe human-entered data that comes from one shop, and this shop A calls a part something, and shop B has slang for another part, and we've seen all that, and we've had to parse a lot of that information. But it's once you have that clean data set and you have it across your company, you can be much more efficient and you can really drive change, and I think that's a great place to start.
Thank you so much for your comments and insights. We appreciate taking time out of your busy schedule and being at the ARC Industry Forum. Thank you so much.